Okay, let's start. I have muted everyone. If anyone has any question, please raise hand. So today I'll talk about multi-agent. So till now we learned that there is one AI agent which has some model attached to it, and then it has access to tools. Okay? And then it has some trigger and then some output. So here the elements in this whole setup is agent and then LLM and then tools and then input and output. So this whole one flow, this setup, you can call talk. You can say it is as task. So you want to upload one file, suppose HTML file, and you want this agent to parse it and then upload to S3. So this everything which this agent does, taking help from LLM and tool, is one task. So in practice, there are situations mostly where you need multiple tasks to be performed. Very basic tasks, but different ones. Like in the resume parser also, there is one task to parse resume or validate resume. So this is a task. This validate resume task is performed by this set. Once the resume comes, this AI agent sends it to the LLM, use some tool, and then validate the resume, either some generic use case or based on some use case fetched from these tools. So this is one task. So after validating the resume, what we want to do is we want to schedule an interview, either cancel this resume or shortlist it, reject it or shortlist it. So for the resume which is shortlisted, we have task schedule interview. Okay. And for the rejected resumes also we have some tasks like send rejection email or send email. So this is one task. We can either directly send using some automation node, or here also we can use agent to create the content for this email. So in just simple use case, we have three tasks. And after the interview is scheduled, again, like it will send some email. So this task will be reused again and again by different tasks. So interview is scheduled, mail is sent. Now uh, we need to start the interview. Now suppose instead of some human taking the interview, we want AI to take the interview. So that will be another task, right? Taking interview. conduct interview. So how this will work? Based on the scheduled interview, we will run a job, and so there will be a job, a cron job, a scheduler running, which will pick, okay, 4 p.m. there is an interview. So one agent at 4 p.m. it will use a Zoom tool and connect to the Zoom meeting. Right? Agents can also connect to Zoom meetings, record meeting, summarize it. So it can at 4 p.m. connect to the Zoom meeting using this tool. And next task would be subtask inside this. After joining, what will it do? It has access to the resume and the job profile. So it will generate some questions, and then it will ask the questions in written format, like in text format or voice format. That depends on the tool or the media or the output you have assigned. It will generate some question. You can display it using a screen or mic or video or anything. So question will appear here. The candidate will join the meeting. They will see this question. They will answer it. This agent will record this answer. So it will suppose ask 10 question. Candidate will give 10 answers. It will make it a record and save it in the database. Now one agent analyze the result, right? So it will keep on running on a schedule. It will pick output. It will pick the this record which is saved by this agent. It will pick it from the database. It will have access to the job profile, resume, question, answer, everything. Then based on the prompt we have given, it will analyze the answers, and it will create the report, whether the questions are correct or not, how many questions are correct. It will create a report, and based on that it will create a result that it is a candidate is selected or not. So based on the result, it will again send an email that a candidate is selected or rejected. You have been selected, you have been rejected, mail will be sent. So this send email will also become a task. Okay, so there is some limitation. I'll use, let's keep this. So now in this one interview process, there are 5 tasks performed by 5 agents, and each agent has access to LLM. Now depending on the task, what it will have. So every task or every agent will have same thing. It will have a prompt, right? I mean, it will have same list of things but different content. So all tasks will have this agent and LLM, and LLM will have some prompt, but this prompt will be different in each of the task. It it can have different AI models, right? Based on the requirement, there are different types of models for that task. If we want to analyze something, if we want to predict something, if we want to classify something, we have models for different tasks. So these models can be different in all the tasks, and the tools, of course. Right? Tools can be different, and every task will have some result. And suppose for metadata purpose, for description purpose, we'll have some description about the task, what this task is about. Okay, so task description and actual task, what it's need to do and what it will return. So every task will have these set of things: a prompt, model, tool, description of the task, the actual task, what it needs to do, which will be detailed in this prompt, and the result. And the most important part is these agents work together. It's not that this agent, this task will get some input, handle this task, and finalize the output, and then some human will give this task to this agent or this output to this task. They will coordinate between them. Now, this coordination, when there are simple coordination that after this step, we have to do this step, after this step, we have to do this step. It is simple. There is no extra process. Once this output comes, we need to attach the here. That's it. Okay. So these are simple flow. But if you go even further in the complex scenario, based on the output, somebody needs to decide which tasks to do. Here also, like if resume is selected, then schedule interview. If it is not, send email. This is also if else case. But there can be multiple scenarios where you have to choose between 10 steps. If this exists, choose between 10 tasks which needs to be performed. Right? So from one simple task to multiple tasks to very complex tasks, there you need some more controller which can act as a leader or manager, which can decide after one step how to start another step, which step to start, which task to perform. So in any system, whenever such things are required, like there are multiple systems and somebody needs to coordinate between them, so that step is called orchestration. Orchestrating this whole flow from one step to another step, how things will go, what will be the output, what will be the input. So this orchestration is also done by this multi-agent framework. So every multi-agent framework has this orchestration node, right? So when there is a simple use case, we don't need orchestration. But there are when multiple nodes, complex multi-agent system is there, we also need an orchestration. So when I talk about this Crew AI framework, it has some orchestration node also, which takes care of all this flow, how this works. So what happens is, suppose you want to book a ticket. So first you want to, so the agent will find out the itinerary, and then based on the itinerary and the availability and the pricing, there will be multiple factors. If price is matching, if the dates are matching, right? You have found an itinerary. Okay, I have to go to Goa for 5 days, but when to go, right? How to go, and who all will go, depending on everybody's schedule. We have to book the ticket. So in that case, there will be lot of decisions been taken care of. So that is done by an orchestrator. So this is the basic of an multi-agent system where we have different tasks. One task has agent and all the related parties in this, the basic things which every task need. And then every task, how they will communicate based on the complexity, we have orchestrator. So in N8N, which is a low code tool or no code tool, we have nodes. Like, right, we have some agent we drag from here, and we need the LLM, we drag here and then attach. But when I talk about programming, when we want to do this using Python or some other programming language, how this will look like. I want to show you a glimpse of how you convert this architecture, this drag and drop diagram to code structure, to Python or maybe JavaScript, right? So this n, you don't know how this works. You don't know whether it is written in Python or it is written in JavaScript or even Java. You don't know. This is just a low code tool. You don't know the coding structure of this. And whenever you want to convert this to a code, you can convert it into a JavaScript or into Python or Java. It doesn't matter which framework, which language you choose. Only thing is, only question would be whether that framework, that language supports this framework or not. So the point here is, if I talk about Crew AI or other famous agent, multi-agent frameworks, they are mostly written in Python, not in JavaScript. Basic AI frameworks are there in JavaScript, but agent frameworks or multi-agent frameworks are only written in Python. So when things get complex, n8n becomes limited. You cannot do everything in n8n. You cannot do everything at low cost in n8n. When things get complex, n8n cost rises. So many clients switch to programming, custom solution. Custom solutions means programming, means Python. Only solution here is Python. You cannot do this in Java. You cannot do this in JavaScript because you need some AI framework, AI agent framework. You can do this from scratch in any programming language, but you have to do everything. But if you want to use framework, then for now only Python is available. So I'm just telling you today how we bridge between this to programming. I mean to Python, right? What is the trigger for switching this to Python or any code? First thing is the limitation. Low code, no code tools are for standard use cases. If you have some custom use case, it won't work. And if the things get complex, the cost rises. Then people say, okay, I'll build it myself. So when you want to build it yourself, the solution is programming. And for AI agent, the solution is Python. So I need to convert this to Python, but I will transition through a pseudocode, not directly into Python. So how you convert this to a code, to a Python, how this looks like. Okay, so I'll talk about that. So for now, let me know if there are any question on this multi-agent architecture or whatever I talked about. If this is clear, how this will coordinate, what is orchestrator, let me know. Any question? Right, so today is 11th July, it's 11th days. We have started from very basic. Now this is the transition period towards something real. Just tell me this is clear or not.
Sir,
Yes,
are you
sir.
recording the lecture?
Yes.
सर नेटवर्क इशू हो रहा है तो सर ग्रुप में भेज दिएगा ना.
ठीक है, बट जिसको भी समझ मतलब नेटवर्क इश्यू नहीं है उसको समझ में आ गया.
Yes, sir.
Right, so before switching to these things, I was expecting everyone to complete the current task. so that you don't lag behind. So this is just first lecture on this. I'll in next lecture I'll again repeat and go in detail. But and today I'll just demo of one snapshot of converting this to a code, right? So my expectation from this session, from this whole training, is you to complete the NA10 task. Python is not mandatory, but you should understand. Okay, so let's talk about how you convert this to Python. Okay, so in programming, like here in low code, we have nodes, right? But in Python, what, or in any JavaScript or any programming C++ you have done, for nodes, what will be the corresponding architecture? Objects, right? Notepad. Okay. So in programming, we have classes for everything. So what will be the classes here? Every node, the agent class, then LLM class, then tool class, and then orchestrator, right? So here I have not drawn orchestrator, but there will be one orchestrator class.
So shouldn't tool and LLM be properties of the agent class?
No, properties will be system prompt, and when you open the agent, whatever you see, those are the properties.
But
But
sir,
these,
LLM and tool are like needed by the agent itself to function.
yeah, so these objects will be connected. This object will be connected. But properties are like what agents look like, what system prompt it has. So properties of an LLM would be name of the model, size of the model, context of the model. So those are the properties. But individually, these are different things. Agent is different, LLM is different, tool is different. Like here, it's a node. This is also node, this is also node, this is also node. These are connected. So here also, these are objects which will be connected. And how these, yeah, what you're talking about is task actually, right? So here, as I said, so when you combine everything, this becomes a task. So same way, we will have a task object, and then combining multiple tasks through orchestrator. So these are the classes, and what we will do is we will create instance of these classes as object. So we will do like new agent, and then we will pass the properties like name of the agent, system prompt, and etc. So these are the properties. So we will create one agent, we'll give it some name, we will give the system prompt what it has to do. So we'll get one agent, agent one equal to new agent. And then what we want? LLM. This LLM node we want. So we'll create a new LLM and name, some name, and then model name or model like ChatGPT, OpenAI, or Gemini, or those things, and other properties. So this way we will create one LLM no, object. So for every node in low code, we will have one object in Python. And then tool one, new tool, name of the tool, and whatever the tool is about, suppose app name, or Yeah, tools are apps. So this name is the name we give, and this is the tool actually serp tool or S3 tool or Google Drive, that app name, and then key and other properties we provide. Right. So this way we create these objects. Now we can have multiple tools, one of A, one of B, one of C, like that. Right. So we create all these building blocks, and then what we will do? We need to connect them. How we will connect them? Using this task. So now we'll create task 1 as new task, and it will have some name. And then what this task will have apart from name? It will need agent, LLM, and tools, right? Two array of tool. I hope this is clear. Everyone is second sem and no programming, so this shouldn't be a foreign thing. So we'll create agent, LLM, tool 1 A, tool 1 B. So separately we'll create all these elements and we'll create a task. Now suppose there is only one task. We don't have multi-agent system. In programming, just this thing. So what we can do is task dot run. Right? There will be some property to run it, and there will be some input maybe here, like we provide some HTML or something. So there will be some trigger function. So it will run. And after running, it will give some output. And this output we will either save or output console. So this way we convert this NET and agent system to Creo AI, or we can say Python, right? So when we have simple task, single task, we run this task. But now, as I said, in case of multiple task, we don't run the task itself. Okay, so agent 2, LLM 2, tool 2, task 2. And then what we need? So if there are suppose 4 or 5 tasks, so we need an orchestrator, right? So we need an orchestrator equal to, and then we provide all the tasks here.
Sir, what's an orchestrator?
So orchestrator is the middleman to handle all these tasks. So it will know when to run which task, when this task will complete, which one to pick, agent 2 or task 2 or task 3, what will we need to put. So in simple term, it's a ringmaster. So when there are multiple nodes, there are always one orchestrator in any. If you talk about software deployment, there are many servers, and then we have one orchestrator server. So it's like a ringmaster which handles all these tasks. So we will pass all the tasks to this orchestrator, and then some decision capability that what is the actual thing we need. So based on that, this orchestrator will perform the task. Right. So now the question would be how this orchestrator will know after this task which task to pick. Okay, so we'll come to that. So once this orchestrator is created with all the tasks, we run the orchestrator. Now the important part, there are two things. Either this orchestrator will take instruction from us, we will pass some uh, logic, some program to decide which task to look for and after which task to perform, right? So that will be a semi automatic multi agent system. Semi automatic means these tasks are automatic, but orchestrator is not automatic. We are telling this orchestrator which task to perform after which task. This whole flow, how to run. If email is validated, then what to run. If it is not validated, what to run. If tickets are available, if there are 3 dates to choose, which date to choose. So these things we will let the orchestrator know, and then based on the instructor, it will handle this task. It will not be completely automatic, right? And then comes the real thing, that is fully automatic multi-agent system, and that is where the game changes, and that is where startups are building their startups. Everything is automatic. We don't have to, one second.
Sir, you are not audible.
सर वॉइस नहीं आ रही है सर।
मेरा वॉइस कट गया था क्या? ओके, सो दिस इज द बेसिक। अगर ये समझ गया हो तो फिर नेक्स्ट लेक्चर में विल ट्राई टू डू सम रियल कोडिंग। एनी क्वेश्चन? कोई क्वेश्चन है?